Today I am going to explain about light reflection and refraction. Light reflection and refraction. So here you can observe. So whatever I am explaining the topic, it's completely about light reflection and refraction. Grade 10 CBSE Physics. Grade 10 CBSE Physics. So plane mirror I am considering. Plane mirror. I am taking the plane mirror. So you can observe. So you can observe on the screen. So you can observe on the screen. So here this is about reflection of light. Reflection of light. Okay. So I'll explain once again from starting onwards. So you can observe carefully. So light is a form of energy which gives the sensation of sight. Light is a form of energy which gives the sensation of sight. When light falls on the surface, it reflects back. It reflects back into the same medium. So the bouncing back of the light is known as reflection of light. The bouncing back of the light is known as reflection of light. So here I am considering, today I will explain that I will explain about light reflection topic. Light reflection topic. So here I am considering here. So this is a plane mirror. This is a plane mirror. Plane mirror I'm considering. Plane mirror here. This is a plane mirror. So when light incident on it, so I'm considering here. This is a plane surface. So one side is a reflecting surface, another side is coated one. Okay. So I'm considering like this. I'm considering like this. This is the incident ray. This is the incident ray. So this will be the reflected ray. Incident ray, reflected ray. This is the incident ray. So I'm considering whatever this one. This is the incident ray. Incident ray. Incident ray. This one is the reflected ray. Reflected ray. And the dotted line which is perpendicular to the plane surface. The dotted line which is perpendicular to the plane surface. This is the normal line. So I am considering this is the normal line. So you can see normal line. Normal line. Normal. So if you are considering this is the undeviated line, so it is undeviated line, undeviated line. So here you can take the angle between incident ray and normal line is called angle of incident. Angle between reflected and normal line is called angle of deviation. Angle of this is the angle of, we can observe this angle of reflection, angle of reflection, angle of reflection, and the angle between reflected and deviated line, undeviated line is called angle of deviation. Angle of incidence, angle of reflection, and angle of deviation. So angle of incident, angle of reflection, and angle of deviation. Angle of incident, the angle of reflection, and angle of deviation. Angle of deviation. So when light you are taking, so normally there are two laws of reflection. There are two types of laws of reflection. Angle of incident ray, reflected ray, normal line lies on the same plane. So here incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. That is a one point. So loss of reflection. So first point is incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. And coming to the second point is angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So here I am considering angle of incidence equal to angle of reflection. Angle of incident is equal to angle of reflection. These are the two laws of reflection. Two laws of reflection. So here I am taking this the plane mirror. This is the plane mirror. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. The bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called a reflection of light. the bouncing back of the light from the reflecting surface. Here you can see the bouncing back of the light from the reflecting surface is called reflection of light. So here incident ray, reflected ray, normal line, incident ray, reflected ray, normal line, incident ray, reflected ray, normal line, incident ray, reflected ray, normal line. So this is undeviated line. So we are considering this undeviated line. So light ray is without deviation. If light ray passes, how it will passes. So this is undeviated line I'm considering. So now we can say here, if you are taking this angle, so this is how much? 180 degrees. This angle is 180 degrees. So this angle is 180 degrees. So this is the like that angle of incident plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. But from the loss of reflection, how we can write? So angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. So we can take angle of deviation equal to 180 minus 2 angle of incidence. So angle of deviation, if you are taking 180 minus 2 angle of Adarsh, now blah. Hey, hi, Adarsh. Hi. Okay. So now I am considering here. So here instead of angle of incidence, I can take angle of reflection. So instead of angle of reflection, I can consider angle of incident also. So here from this formula, you can see instead of this one, I am writing angle of reflection. Instead of angle of incident, I am writing angle of reflection. So angle of reflection, so plus angle of reflection plus angle of deviation equal to 180 degrees. Then angle of deviation equal to 180 minus 2 angle of reflection. 180 minus 2 angle of reflection. So this is very, very important. So if for the board exam, this question will come. For the board exam, this question will come. So very, very important topic. Once again, listen carefully. So the bouncing back of the light from the reflecting surface. The bouncing back of the light from the reflecting surface is called reflection of light. The bouncing back of the light from the reflecting surface is called reflection of light. So this is the incident ray, reflected ray, normal line. 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 So angle between incident ray and normal line is called angle of incident. Angle between incident ray and normal line is called angle of incident. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and normal line is called angle of reflection. Angle between reflected ray and undeviated line is called angle of deviation. Angle between reflected and undeviated line is called angle of deviation. Angle between reflected and undeviated line is called angle of deviation. So here you can consider from laws of reflection. There are two laws of reflection. Angle of incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. Incident ray, reflected ray, normal line lies on the same plane. And angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. Angle of incident is equal to angle of reflection. So angle of incident is equal to angle of reflection. So like that. So these are the two laws of reflection. Two laws of reflection. So now we can take angle of incident plus angle of reflection plus angle of deviation is a linear pair, that is 180 degrees. So from the laws of reflection, angle of incident equal to angle of incident is equal to angle of reflection, right? So instead of that, I am writing here. So you can take angle of incident plus angle of incident plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. And here, so angle of reflection plus angle of reflection plus angle of deviation equal to 180 degrees. So angle of deviation equal to 180 minus 2 angle of incidence. So we can write in this two manner. So if they ask this related to problems, we can also follow this formula. Okay, so this is about angle of deviation. Next, I'm going to the next topic is so next, what's the next topic? Next topic, if you come to that regular reflection, irregular reflection, I'll explain. Regular reflection and irregular reflection. Regular reflection and irregular reflection. So here I'm considering. So here if you are taking the plane surface, so I'm taking the plane surface. Hi sir, I am new student of your channel. Hi Shivam, how are you? Welcome to the Student the Brand channel. So here I'm considering. So every day at 9 p.m. I'm taking live class. So remaining time also I will take. But 9 o'clock is fixed. 9 o'clock you can constantly attend to the class. So attend to the 9 o'clock class. Okay. So you'll be getting the abundant resources. So today at 9 p.m. I'm taking electricity chapter, CBSE Grade-10. So remaining time I will be taking. So 9 o'clock you can constant time. So that is fixed one. So you can join, right? So now also you can listen the class. Done. So I am taking this regular reflection, regular reflection, regular reflection, regular reflection. So what is a regular reflection? Regular reflection is nothing but, so when the incident beam is parallel, so I am taking this incident beam. So this incident beam like this. So incident beam is parallel, then reflected beam also parallel, then the type of reflection is called regular reflection. So if you are considering like this, if you are considering like this, so incident beam, incident beam, incident beam, and this is the reflected beam, reflected beam, reflected beam. So both are parallel to each other. So incident beam is parallel, reflected beam. Sir, you will teach 9th class topics also? Yeah, I'll teach 9th class topics also. सर आपने फ़ोन के स्कैनर क्या रखे हैं? Actually here this so CBSE Grade-10 Physics, CBSE Grade-10 Physics by Siva sir, BTech Mechanical. So 10 years experience in physics teaching. So I started the course. The course is what is that course? CBSE Grade-10 Physics. CBSE Grade-10 Physics. Light reflection, diffraction, human and color field, electricity, magnet effects of electric current. So these 4 chapters I am providing like a course. I am providing like a course explanation. So you can see that my channel group icon, my channel icon also you can see that only. So regarding that only it is there. So about the course. So that only. So 500 rupees. So I kept the price. That's the reason I'm. So it's a phone number. So if you want more details, you can contact to this number. So that's the reason I kept like that. Okay. Done. I'll teach Pragyan, Justin Raj. I'll teach 9th class physics also. 9th class physics also I'll teach. 6 to 12. JE and NEET also I'll teach. JE and NEET for them also I'll teach. So it's going on. Present right now I'm going to the grade 10 physics. So slowly I will start because it will take time, right? That's fine. Okay. So if you need further details, you can contact to this number. It's a WhatsApp number. So further details, further things. And the 9 o'clock class is fixed one. So everyone join to the 9 o'clock class. 9 o'clock class, which you will be, that time you'll be getting more extraordinary concepts. So we will discuss problems. Practice session will be there. Concepts will be discussed in detail, in depth. So because everyone will join now. So I'm asking this class. So concept plus at the same time 9 o'clock regarding 9 o'clock's class to explain. So I'm taking class now. 9 o'clock is fixed. Many of the students will join to the 9 o'clock class. So join to the class, everyone. And even 9th class also I'll teach ma. So Justin Raj, I'll see. Here I'm considering incident beam is on parallel. You can see plane mirror, smooth surface. This is a smooth surface. Smooth surface. Regular reflection takes place on smooth surface. The smooth surface is plane mirror. So I'm taking the plane mirror here. Plane mirror. So here I'm considering incident beam. So reflected beam. Incident beam is a reflected beam. So smooth surface, that is a plane mirror. Smooth surface, that is a plane mirror I'm considering. So this the plane surface. This is a plane surface. This is a plane surface. Okay. So the here incident beam is parallel, reflected beam also parallel, that type of reflection is called regular reflection. Whereas irregular reflection, if you see, irregular reflection, irregular reflection, irregular reflection, irregular reflection. So irregular reflection I am considering now. So you can observe. So I am taking here. So incident beam is parallel. Incident beam is parallel. Incident beam is parallel, but reflected beam is not parallel. Reflected beam is not parallel. So incident beam is parallel, but reflected beam is not parallel. This type of reflection is called irregular reflection. So this type of reflection takes place on rough surface. This type of reflection takes place on rough surface. Rough surface. Okay. So rough surface, like this we can take, like we can consider this rough surface, book, wall, paper. Okay, so book we can take, wall we can take, paper we can take. So irregular reflection takes place on this. So whereas smooth surface, plane mirror only. This is about regular reflection and irregular reflection. So now I'm going to the object and image. So object and image. So I'll explain object and image. Object and image I'll explain. Okay, so object and image is very important. So now I am explaining. So here I'm taking this the plane mirror. So coated one. So here it is coated. So I'm taking the plane mirror. So principal axis. So here is the incident ray. This object I'm taking AB. This object AB. Object AB. One light ray I'm taking like this. So how many light rays are required to form the image of the object? How many light rays? 2 light rays. 2 light rays are required. 2 light rays. 2 light rays. 2 light rays are required to form the image of the object. Minimum 2 light rays are required. So I am considering one light ray here. So another light ray I am taking like this. So it reflect back. And one more light ray I am considering like this. So it will reflect back. Okay. So now I am considering here object and image, right? This is about plane mirror. So object and image. Object and image I am explaining now. So here I'm considering the object. Object O. So this is the object O. One light ray I am taking like this. So this is one light ray. Incident ray. So this is the reflected ray. So I'm considering one more light ray like this. So it will be reflected. Right. So I'm considering like this. So if you are extending, see here, how many light rays are required to form the image of the object? Minimum 2 light rays are required. Minimum 2 light rays are required, right? Minimum 2 light rays are required to form the image of the object. So here I am considering, so this is one light ray, this is one light ray. So it will be reflected back. This is reflected back, here also reflected back. If you are extending this light rays, so you can see, if you are extending this light rays, so their image will form, that is a virtual image. Image will form virtual image. So here is a object, real object. So here is a real object. Here is a real object. So object, the light rays will come. Light rays are coming from this object. Light rays are coming from this object. So one light I am taking like this. Another light I am taking like this. So these are the reflector light rays. If you are extending this is the incident ray and this is the incident ray, those light rays will incident. We are extending those light rays. Those light rays are meeting at one point. Extending light rays. So we are extending the light rays. Those light rays are meeting at one point. So their image will form. That is a virtual image. That is a virtual image. Okay. So here is virtual image is forming. So what type of image is forming? Virtual image. What type of image is forming? Virtual image. Virtual image is forming, right? So the point of intersection of extended reflector light rays. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of incident light rays. The point of intersection of incident light rays. The point of intersection of incident light rays. So here the point of intersection of incident light rays, the point of intersection of incident light rays is called real object. The point of intersection of extended reflector light rays, the point of intersection of extended reflector light rays is called virtual image. The point of intersection of extended reflector light rays is called virtual image. So image will form here. That is what is the nature of the image? Virtual image. Okay. So virtual erect and diminished image will form. And here object is real, image is virtual. Object is real, image is virtual. I'm taking one more. So here is light rays are coming from infinity. How many light rays are required to form the image of the object? Minimum. How many light rays are required to form the image of the object? Minimum 2 light rays are required. Minimum 2 light rays are required to form the image of the object. So I'm considering here. So these light rays you are extending. So here. So this is the virtual object and this is a real image. This is a virtual object and real image. Virtual object and real image. So here you can see the point of intersection of incident light rays. The point of intersection of incident light rays is called virtual object. The point of intersection of incident light rays is called virtual object. The point of intersection of incident light rays is called virtual object. The point of intersection of incident light rays is called virtual object. The point of intersection of reflector light rays. So this is the incident ray. This one is the incident ray. This one is the incident ray. This one is the reflected ray. Okay. So these reflector light rays are meeting at one point here. This reflector light rays are meeting at one point. Aditya Rao. Hi everyone. Hi Aditya Rao. What's up guys? I am also here Aditya Rao. You can say hi to me also. So here I am taking these are the reflector light rays. Reflector light rays I am taking. This reflector light rays will meet at one point here. This reflector light rays will meet at one point. Okay, so that is a real image. So here virtual object. This is a real image. The point. Hi. So thank you. So the point of intersection of reflector light rays is called real image. The point of intersection of reflector light rays is called real image. Here the point of intersection of incident light rays. The point of intersection of extended incident rays. The point of intersection of extended incident rays is called virtual object. The point of intersection of extended incident rays is called virtual object. The point of intersection of extended incident rays is called virtual object. The point of intersection of reflector light rays. Directly light rays are meeting, that is their image will form. That image is called real image. So here you can see, here you can observe in this condition. So this is a real object, this is a real object, and this is a virtual image. Real object and virtual image. Real object and virtual image. So here the incident light rays are coming from this point. Incident light rays are coming from this point. Here you can see reflector light rays. So we are extending this reflector light rays. Those light rays are meeting at one point. So we are extending this reflector light rays. Those light rays are meeting at one point. So that is called virtual image. The point of intersection of extended reflector light rays is called virtual image. The point of intersection of new Cartesian sign convention, new Cartesian sign convention, all distance measured from the pole. Distance opposite to along the instant trace. Distance negative opposite to instant trace. Distance opposite to above the principal axis. Distance negative below the principal axis. Oh my God! Why suddenly started singing? So it's like a break in between a movie. So there is a break in between the serial. There is a break like this. No, suddenly ad come and go. Here also, this is the one ad. So this is also a concept. This is also a concept. Okay. So this is a concept. It's not a song. So don't feel like that. So sorry, singing songs. It's not a song. So it is a concept that is you'll get to know. So in further. So next. Within few minutes only you'll get the concept. So that is light ray, new sign conventions. That is about sign conventions. I sang a song. Okay. Okay. So come to the point here. So these are the reflector light rays. These reflector light rays are meeting at one point here. That is a virtual image. So here these reflector light rays are meeting. So their real image. So here you can understand the difference between real image and virtual image. So this is a real image. So this is a real image, and this one is a real and virtual image. Real image and virtual image. Real image and virtual image. Here, real image means directly light ray, sir. Sir also know the song. I also know the song. How do you know that song? In the same channel. Okay, so take time and comment. So meanwhile, I'll teach the concept. Sir, you only sang in the class. Oh, yeah, great. Very nice. So, carry on. So here, reflector light rays are meeting. These are the reflector light rays. Reflector light rays are meeting. So, extended reflector light rays are meeting. Here you need to join. Sir, I joined this video first time. Hi Rakesh, how are you? Welcome to the Student the Brand. So you'll get extraordinary content with more more popular methods by Shiva sir. Welcome to the class. Welcome to the class. Hi. Oh, Aditya Rao. Okay. So welcome to the class, everyone. Join to the class. So listen the class. See, 9 o'clock you can join. So you get 9 o'clock, join to the 9 o'clock, so you'll get more content, so more concepts. So electricity we are discussing, very important concept, electricity we are discussing. Try to join to the 9 o'clock class. Even though you're joining now, very good. Join to the 9 o'clock class, so you'll get the different methods, problems will do, concepts will explain, everything. So now I am taking this reflector light rays here. These are the reflector light rays are meeting at this point. Reflector light rays are meeting at this point. Reflector light rays are extended reflector light rays, not directly reflector light rays. Extended reflector light rays are meeting at this point. The image will form. That is a virtual image. Here you can see reflector light rays directly meeting. Reflector light rays are directly meeting. So reflector light rays are directly meeting. Reflector light rays are directly meeting. That is a real image. That is a real image. Here extended reflector light rays are meeting. Extended reflector light rays are meeting. That is a virtual image. So reflected real image means, so light rays, see, real object or real image means actual light rays will meet. Actual light rays will meet. Here you can see object and image. So this is the real object, real image. Real object and real image. So in this both the cases you can understand one thing. That is, so if the light rays meet actually, if the light rays are meeting actually, so their real image and real object will form. So whereas extending of incident rays, extending of reflector light rays, then so virtual object, extending of incident rays, extending of reflected rays, so gives the virtual image. Virtual image means extension of reflector light rays. So extension of incident rays is called virtual object. Virtual object. So this is about virtual image and object. Real image and object. Those are real image, virtual image, real object, virtual object. So that's enough. So now I'll go to the next topic. So next topic. So characteristics of the image formed by the plane mirror. So characteristics of the image formed by the plane mirror. So I am considering now. So you can take. So if the plane mirror, I am considering this a plane mirror. So here I am taking the plane mirror like this. So here I am considering the plane mirror. So this is a plane mirror. Okay. So this is a plane mirror, plane mirror, plane mirror, plane mirror, plane mirror, plane mirror. So here I am considering like this. So normal line I am taking. Normal line. So here I am taking the object. This object, size of the object is AB. AB is the size of the object. AB is the size of the object. So 1 liter I am taking like this. So 1 liter I am taking like this. 1 liter I am considering from here. So here I am taking, how many liters are required to form the image of the object? Minimum 2 liters I said. 1 liter I am taking like this. Another liter you can take here. You can take like this 1 liter. And here also 1 liter I am taking like this. And here also. Okay. So now you are considering. Here. So these are the dotted lines. And here also dotted lines. And here also dotted lines. Dotted lines. So here. Sir, why you are drawing with the dotted lines? Because the image is virtual image. Sir, doubt. What is your doubt? So the image is virtual image. Yes, this is the mirror. Plane mirror. Plane mirror. This is the plane mirror. Yeah. So this is the object, right? This is the object. So object is here. Object is here. This is the image. Image. And the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Once again, the distance between object to mirror is called object distance. The distance between mirror to mirror, this is a mirror, this is a plane mirror. So this center one is plane mirror, this one. Okay. So the distance between plane mirror to image is called image distance. So here there are 3 points are there. Point number 1. So point number 1 is object is real, image is virtual. 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 Image is virtual. So object is virtual, image is real. Image is real. So like this we have to take. So here you can see object is real, image is virtual. Object is virtual, image is real. So vice versa. If the object is real, image is virtual. So like that we have to consider. Like that we are considering. Now you can take. So this one more second point is object distance is equal to image distance. Object distance is equal to image distance. Object distance is equal to image distance. So why? So if you are taking the plane mirror, if you move in front of the plane mirror, so if you move, so how much of distance you move, so same distance the image also will move. The same distance also the image will move. So the distance between object to mirror is equal to the distance between image to mirror. So object distance is equal to image distance. And coming to the third one is height of the object is equal to height of the image. Height of the object is equal to height of the image. And fourth one, it shows the lateral inversion. It shows the lateral inversion. So lateral inversion. inversion. So what is meant by lateral inversion? What is meant by lateral inversion? Lateral inversion is nothing but, so the phenomena of converting, of left side of the object appears to be right side of the image. Left side of the object appears to be right side of the image. Right side of the object appears to be left side of the image. Right side of the object appears to be left side of the image. So this is about this mirror conversion is called, this mirror image is called, image is called lateral inversion. This mirror image is called lateral inversion. So there are 4 points. So here object is real, image is virtual. Object is virtual, image is real. Object distance is equal to image distance. Height of the object is equal to height of the image, and also it shows the lateral inversion. So these are 4 points, very very important points related to plane mirror, plane mirror. So I hope it is clear to you all. So shall I go to the next one? Next we'll go to the spherical mirror. So the only spherical mirrors left. So related to spherical mirror, even refraction of light is there. Refraction of light. So refraction of light in this topic, still few more points are left. Few more points are related. We can go for spherical mirror, terms related to spherical mirror, ray rules and image formations, ray rules and image formations, and the next one, sign conventions. Just now I sang the song, no? That is only sign conventions. And the next one, mirror formula, magnification, mirror formula and magnification. Next one, so we are going to the one more point, that is about refraction. Refraction also it will take time, nearly 1 hour, 1.5 hours it will take time. Okay, so this remaining topic. So those who are interested, you can join to the class. So again, I'll take class. So after half an hour, so after a break, 10 minutes break, I'll give 10 minutes. So take 10 minutes break then, instead of half an hour. You can take 10 minutes break. Again, I'll teach the next topic. 10 minutes break. Ten minutes break. Then I will explain a remaining topic. Clear? Thank you. Hi everyone. So we are going to the next one. Till now we discussed about plane mirror characteristics. So nature of the image formed by the plane mirror. So now we are going to the next one. That is about spherical mirrors. So now I will explain about spherical mirrors. So the mirror which is in the form of curved surface, that is called spherical mirror. The mirror which is in the form of curved surface. So the mirror which is in the form of curved surface. So here you can see. Here you can see I am taking now. So spherical mirrors I am considering now. So here I am taking the mirror which is in the form of curved shape. The mirror which is in the form of curved shape. So we are taking the small portion. We are considering the small portion. So we are taking the small portion here. So small portion, right? So this is a small portion. That is nothing but curvature. Small portion is called curvature. When light incident on it. When light incident on it. Okay. So based on reflection, based on reflection, based on reflection, we can see based on reflection, the mirror will decide. So what type of mirror it is? Concave mirror, convex mirror, concave mirror, convex mirror, based on the reflecting surface, based on the reflecting surface. So here you can see if the reflection takes place inward. So I'm taking the this plane mirror. So reflection taking place inward. Inward is called concave mirror. Reflection taking place inward. Whereas convex mirror, you can see convex mirror reflecting takes place outward. Reflecting taking place outward. So I'm taking the convex mirror. So like this I'm considering now. So reflection takes place outward like this. Reflection takes place outward. Okay, so we are extending this light rays. Here also we are extending. Here also we are extending. So this is a concave mirror where reflection takes place inward. Concave mirror. Concave mirror is also known as converging mirror. Concave mirror is also known as converging mirror. Sir, why you are considering concave mirror is a converging mirror? Concave mirror. Concave mirror. So here convex mirror. This is a convex mirror. So concave mirror is also known as converging mirror, whereas a convex mirror is also known as diverging mirror. Why we are saying convex mirror, concave mirror is a converging mirror? Because whenever the light rays are incidenting on it, after reflection, immediately light rays will meet at one point here. So after incidenting, light rays will meet at one point here. So their image will form. So what is the nature of the reflector light rays? So after reflection, those light rays will meet. So those light rays will move towards the principal axis. Those light rays will move towards the principal axis. Those light rays will move towards the principal axis. Those light rays will move towards the principal axis. So those are converging. Best example, so you are going to school. You are coming from different places and reaching to the school. So you are coming from different places, right? From different places you are coming to school. So that is converging. So in the evening time, you can see from same place you are moving in different directions. So here also I am considering. So if the light rays are coming after reflection, those light rays will meet at one point here. So this a concave mirror is also known as converging mirror. Converging mirror. Converging mirror. Converging mirror. So here convex mirror is also known as diverging mirror. Diverging mirror. Diverging mirror. Diverging mirror. So convex mirror is also known as diverging mirror. So why we are taking convex mirror as a diverging mirror? So my point is, so why we are taking convex mirror as a diverging mirror? Because whenever the light ray incident on it, after reflection, those light rays are moving away from the principal axis. So here you can see, so this is the principal axis. So I'm considering this is the principal axis. This is the principal axis. This is the light ray. So whenever the light ray incident on it, this will be reflected back. This reflected light rays are reflecting back. So this reflected light rays are reflecting back. So you can see. So moving away from the principal axis, moving away from the principal axis. So diverging the light rays. Those light rays are diverging. 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 Okay, so that's why it is called diverging lens. That's why it is called diverging mirror. This is a concave mirror, this is a converging mirror. Here convex mirror is also known as diverging mirror. Convex mirror is also known as diverging mirror. Sir, why are you talking class on this time? Aish, so I'm taking physics 24/7. 24/7. This channel will teach physics 24/7. So except apart, having lunch and everything. So that's why I'm taking now. Okay, so night time is this time is fixed. 9 o'clock is fixed. So remaining time also I'm teaching. So if you are joining, join. So anytime you can join. Apart lunch time, done, sure. So 9 o'clock is fixed. 9 p.m. is fixed. Remaining time also you can join and listen the class. So chapters will go on. But that class will continue. So as it is, it will go. Here also same thing. So sequence will be there. But 9 o'clock is everyone will come and join. No, that's fine. I will teach that time. Okay. So now we can go for apart. I already said 24/7 in the sense we can't go for 24/7. But apart lunch and dinner, morning breakfast, so we have to eat food to talk. No, so that's why apart those timings, apart sleeping timings, so remaining time I'm taking classes. So so physics related to physics only continuously I'm dedicating my time to work out. Okay, so next we'll go to the next one. So concave mirror, concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror. Concave mirror is also known as converging mirror. Convex mirror is also known as diverging mirror, right? So I'm going to the next one. So now you can see one more point. Ray rules. Ray rules will go with the ray rules. Ray rules of concave mirror. Ray rules of concave mirror. Concave mirror. Ray rules of concave mirror. Ray rules of concave mirror. So I'm considering here. I'm considering here. So this we didn't discuss about terms related to spherical mirror, right? So I'll discuss about terms related to spherical mirror. Then I'll come to the ray rules. Ray rules. Terms related to spherical mirror. Terms related to spherical mirror. Terms related to spherical mirror. So yes. So I'm taking here. So big announcement. It's a big announcement for terms related to spherical mirror. So I'm considering the concave mirror. Concave mirror. No, only one time only we have to take. So here. So this is a sphere. This is a sphere. So here I'm considering this is the center of the sphere. This is the pole. This is the pole. So this is the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So this is the pole. The line joining of center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. First one is pole. Second one is center of curvature. Third one is principal axis. Principal axis, the line which is passing through center of curvature and pole is called principal axis. The line joining of center of curvature and pole is called principal axis. So the distance between center of curvature to pole is called radius of curvature. The distance between center of curvature to pole is called radius of curvature. So after reflection, this is the radius of curvature, 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 radius of curvature. Yes, so after reflection, light rays will meet at one point on the principal axis. After reflection, light rays will meet at one point on the principal axis. That point is called focus. That point is called focus. That point is called focus. What is that point? Focus. What is focus? After reflection, light rays will meet at one point on the principal axis called focus. So, what is focus? After reflection, light rays will meet at one point, the principal axis. What is that point? Principal axis. Sorry, focus. Principal focus. So, this point is also known as principal focus, or simple terms, easy terms. So we can take focus. We can take focus. And sixth one is the distance between focus to pole. The distance between focus to pole. The distance between focus to pole is called focal length. Is called focal length. Is called focal length. Focal length can be denoted with a small letter. Focal length can be denoted with a small letter. Focal length can be denoted with a small letter F. Then seventh one. So we can take seventh one. What is seventh one? Width of the mirror, diameter of the mirror, or reflecting surface is called aperture. Aperture. It is called aperture. Aperture is nothing but, so wherever a reflecting surface. Hello sir, today English paper is good. I did it. I can probably get 34 marks out of. Nice, Anhad. So very good. So do rockin' in our exam. Okay. Physics also you must get physics target for out of out. No other target, right? Okay. So come to the point. So pole is nothing but. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. The center of the imaginary sphere. Center of the imaginary sphere in which mirror is a part is called. Okay. No. Whenever exam comes, whenever science exam comes, that time you have to do good. Like that I'm saying. Okay, done, fine. So here, the midpoint of the mirror is called pole. And center of the imaginary sphere in which mirror is a part. So the line joining of center curvature and pole is called principal axis. The line joining of center curvature and pole is called principal axis. Okay, the line joining of center curvature and pole is called principal axis. And radius of curvature. Radius of curvature is the distance between center curvature and pole. The distance between center curvature and pole. The distance between center curvature and pole is called. Actually, I can teach. So I'm good in science. But see, completely dedicating to the physics. Okay, so if I teach physics, it will be entire like JEE NEET students also. It will be helpful from 6th to 12th. 6th to 12th, it is like a stream now. That's why I'm teaching physics. So I like the physics the most. So that's why I'm teaching. I'll try. I'll try with the remaining subjects also. But as of now, so I'm going with the okay. So with the physics, always physics, only physics. So remaining subjects also we will work out. But as of now, J physics. Okay. So here I am considering the distance between focus to pole. Actually, this distance is called focal length. This distance is called focal length. The distance is called focal length. So the distance between focus to pole. Actually, this is also called principal focus. This point is called principal focus, capital letter. So, but we are talking about simply focus. Simply focus. Once again, so pole, central curvature, principal axis, radius of curvature, focus, focal length, aperture. Aperture. Once again, so the midpoint of the mirror is called pole. The center of the imaginary sphere in which mirror is a part is called central curvature. The line joining of central curvature and pole is called. The line joining of central curvature and pole is called. The line joining of central curvature and pole is called radius of curvature. So after reflection, all light rays will meet at one point of the principal axis, that is called focus. After reflection, all light rays will meet at one point on the principal axis called focus. So the distance between focus to pole is called focal length. The distance between focus to pole is called focal length. And aperture, the width of the mirror, the reflecting surface. So where the reflection of light takes place, that surface is called aperture. That surface is called aperture. Clear? So this is about pole, central curvature, principal axis, radius of curvature, focus, focal length, aperture. Right? Yes. PC, PR, F square A. PC, PR. PC, pole, central curvature, PR, principal axis, radius of curvature, F square, focal length, focus, focal length, and aperture. Right? So I'm going to the next one. Next one. We are talking about light reflection and refraction. In that we completed terms related to spherical mirror. Next one we are going to the rules of image, rules of spherical mirror, spherical mirrors, spherical mirrors. Here there are two types of spherical mirrors are there. How many are there? There are two types of spherical mirrors are there. Based on reflection of light. Based on reflection of light. Based on reflection of light. So spherical mirrors are divided into two types. So reflection takes place inward, that is called concave mirror. Reflection takes place outward, that is called reflection takes place inward, concave mirror. Reflection takes place outward is called convex mirror. Convex mirror. Concave mirror is also called converging mirror. Convex mirror is also called diverging mirror. Remember, very, very important points. Concave mirror is called converging mirror. Convex mirror is called diverging mirror. See only one side reflecting surface, another side no reflection. So reflecting surface, if you want to see another side, no reflection takes place. Only one side reflection takes place. That is called mirror. Reflection takes place inward is called concave mirror. Reflection takes place outward is called convex mirror. So here I am considering spherical mirrors. Concave mirror. Concave mirror. Concave mirror. Concave mirror. Concave mirror. Concave mirror. So I am taking one concave mirror. So every time you are drawing the concave mirror, you must place the points. What are those? Pole focus, center of curvature. Pole focus, center of curvature. Pole focus, center of curvature. One light ray I am taking like this. After reflection passes through focus. That is the first point. Coming to the second one. If the light ray is passing through focus, so pole focus, central curvature, pole focus, central curvature, pole focus, central curvature, pole focus, central curvature. Light ray is passing through focus. After reflection, reach to the infinity. Light ray is passing through focus. After reflection, reach to the infinity. So third one, coming to the third ray rule, what will happen in this time? So wait and watch. So pole focus, center curvature, pole focus, center curvature. If the light ray is passing through center of curvature, if light ray is passing through center of curvature, it retraces its original path. If light ray passes through center of curvature, it retraces its original path. So coming to the fourth one, 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 pole, focus, center of curvature, pole, focus, center of curvature. If the light ray is incident at the pole, if the light ray incident at the pole, if the light ray incident at the pole, if the light ray incident the pole, it will reflect back into the same medium. So these are the ray rules of concave mirror. These are the ray rules of concave mirror. So if the light ray is coming from infinity, after reflection passes through the focus. If the light ray is passing through the focus, after reflection moves towards infinity. If the light ray is passing through central curvature, it retraces original path. Here, if the light ray incident at the pole, it reflect back. If the light ray incident at the pole, it reflect back. So this is about concave mirror. It's all about concave mirror. Ray rules. And image formation for convex mirror also we'll discuss now. Same image formations will get it, so no doubt at all. Only 4 image formations are there in concave mirror, convex mirror also. Convex mirror. Oh, convex mirror. Convex mirror. Convex mirror. Convex mirror. Convex mirror, convex mirror, concave mirror, just now completed. Now I am taking the convex mirror. If you are taking the convex mirror like this, pole, focus, center of curvature, 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 pole, focus, center of curvature. Light ray is coming from infinity after reflection passing through focus. So the light ray is coming from infinity after reflection passes through focus. What is that? Focus. Yes, focus. Here is a focus. Second one. So here, my highness, I am taking here pole, focus, central curvature, pole, focus, central curvature, pole, focus, central curvature. If the light ray is passing through focus, after reflection moves to infinity. After reflection, what happens? Light ray will move towards infinity. What happens? Moves towards infinity. So the next one is, if the light ray is passing through center of curvature, light ray is passing through center of curvature, So pole focus center curvature. Pole focus center curvature. So if the light ray is passing through center of curvature, it retraces its original path. It retraces its original path. Next one, fourth one I am taking. Fourth one, rule of light, rule of convex mirror, rule of convex mirror. So I am taking pole here, focus here, center of curvature here. I am taking pole, focus, center of curvature. If the light ray incident at the pole, if the light ray incident at the pole, it reflect back, it reflect back. So these are the ray rules of convex mirror. These are the ray rules of convex mirror. I hope it is clear, everyone. Shall I go to the next one? Is it clear? Everybody, everybody, is it clear, everybody? Okay, done. So is it clear, sir? Come, next one. So we are going to the image formations, image formations, image formations, image formation, concave mirror, image formations. When you are taking the object, according to the object, image will form at point. So now I am considering here, I am taking the object, I am considering the object, I am considering the object. So now 12 o'clock, right? So we'll go for a break. We'll go for a break. We'll go for a break. So you can take break. And then again I will come and join at shall we join again 2 o'clock? 2 o'clock. So those who are there, those who want to join at 2 o'clock, you can let me know. Those who want to join at 2 o'clock. So if not, 9 o'clock class is there. 6 o'clock class is there. Okay, I'm taking at 6 o'clock also. 6 o'clock I'm taking, 9 o'clock also I'm taking. So you can join it at that time. Okay, so according to the timings, 9 o'clock is fixed. This apart lunchtime, as I said, apart lunchtime, I'm taking remaining time classes. I'm taking remaining time classes. So we'll see. So how it we will take. I will plan. I'll give the schedule. So 9 o'clock is fixed. That time I'm taking class. In that time I'm explaining the electricity. Electricity I'm explaining. Electricity chapter, that is nothing but concept and problems. Concept and problems I'm explaining. Okay. So this is your Siva sir from Student the Brand. Thank you. Now, okay, Anhad. So you asked about refraction, right? I will explain refraction. So you message. Okay, done. Bye.